Predictive value stream simulation is our consulting offering where we apply discrete event simulation for operational excellence. In this presentation, I will cover the introduction to predictive simulation, show you the business context for the simulation, and the solution approach that we follow, a typical simulation project, and finally the benefits of predictive simulation. So starting with the introduction to predictive simulation. Value stream mapping is used widely to design and to improve operations. But it's very essential to be able to predict the throughput, the flow time and lead times, work in progress, as well as the utilization of the resources in your operations in order to effectively design or to effectively improve your operations. However, traditional value stream maps are inadequate to do this because they use average values instead of accounting for variability which exists in the real situations. They cannot handle complex flows, that it's difficult to handle the shared resources. Mixed models are almost impossible to account for. Information flows can be drawn on a value stream map, but the effect of it can't be calculated, and when they change, you do not know what's the result. And finally, scenario modeling and experimentation is simply not possible with the traditional VSM approach. And so we do the predictive simulation, which is a more advanced way of doing this thing, where we use discrete event simulation to map out the operations and to also simulate the operations. You can see the material flow, you can see the information flow. When you change the information flow, things change. We can predict on a timely basis, right? The lead times and the throughput, work in progress, utilizations. In fact, anything within the system that you want to predict, right, can be predicted using this approach. So what is simulation? Simulation is a powerful scientific approach for making confident and evidence-based decisions that will improve your organization's output, efficiency, and profitability. Simulation software enables you to build a visual representation of your manufacturing process or business process. You can assign the resources, add rules, and mimic real life behavior. That's the key. Simulation model also allows you to test the impact of process changes and what-if scenarios. It is possible to determine a set of changes that will give you the best operational performance and, of course, a higher return on the invested capital. We use the latest version of Simulate software to perform this discrete event simulation of the operations. Now, coming to the business context for simulation, let's talk about four things here: operations design, operations execution, making step changes, and of course the continuous improvement of operations. In the operations design phase, we can model greenfield and brownfield designs before implementing. We can develop optimal shifts and staff allocations. We can also develop optimal flows of material and informational flows. We can predict throughput, lead time, financials, including the return on invested capital in greenfield and brownfield situations. In case of operations execution, using what-if scenarios, we can develop and test new policies and interventions for making operational decisions. We can develop and test plans to flex operations in the event of changing demand. As far Industry 4.0 is concerned, we can use sensor data for accurate predictive models. Step changes or transformation projects, right? We can assess investments in plant and equipment. We can assess the investments in automation such as robots and AGVs, and the resulting incremental throughput and improvement in lead times and the improvement in the return on invested capital. These things can be done. We can also test and improve and prioritize existing portfolio of change projects. We can analyze operations to find bottlenecks and identify new solutions. These are all in the context of making step changes to your operations. And during the continuous improvement phase, where you're trying to maintain the performance and slightly improving, making little changes, you can validate improvement projects and ideas before implementing using this approach. Our solution approach really focuses on the return on invested capital. Where necessary, we also model the return on invested capital tree, because return on invested capital, ROIC, is the best measure for productivity. We identify the right KPIs and their desired levels for maximum ROIC. And then, of course, we perform the process simulation, where we create the models to mimic real-life behavior of your operations, and we can baseline the current performance and test improvement scenarios. We also develop operating curves where necessary, because operations follow established laws, and we can create custom operating curves for your operations and assess the performance and identify the operating zone, the lean zone, for maximum ROIC position. Let me quickly introduce to you the ROIC mapping approach and the operating curves. So ROIC map is where we actually create a tree where all these values are interlinked. We calculate the return on invested capital based on the financial figures, and they are linked to the operating parameters, where even the little slot, throughput, flow time, and work in progress and other operational KPIs are linked together to the tree. Okay, and we use this information, the operational information, and simulate, of course, to create what is known as operating curves for the operations. Obviously, what you have is a best case, a theoretical case, which is a blue line, and we have a simulated case, and we identify a lean zone where you need to go, where are you currently at the moment, etc., and we target a position, and then we find solutions to reach that position. This is an example of a simulated throughput versus work in progress curve, the red curve. The red dot is where you are currently, and then we target a position where to go, potentially reducing work in progress, staying almost at the same throughput, and the effect on the flow time is that the flow time versus work in progress curve, again you have a simulated one. At 60 work in progress you have a high flow time, but we want to reduce the flow time by reducing the work in progress. Once we conceptually figure out our target, how do we want to move in the operations, then using a simulation and of course scientific principles, we identify the solutions and test and validate the model. Now let's look at a typical simulation project approach. Simulation project phases are 3 of them here, as you can see. As is, simulation model is initially developed, verified and validated. We get the scopes and specs and assumptions, etc. We get the data, build and test the model, and verify with the stakeholders. In the end, if you want to use that model to simulate for yourself, we can provide the instructions to use, how to use the model, and we also document what we have done. Now, the next phase is obviously a what-if scenario analysis. You may already have some ideas that you want to test, or you are actually starting to implement, or you have a bunch of projects. So we agree what-if scenarios. We agree what are the KPIs we would use to evaluate these what-if scenarios. We obtain the financial information and build a financial model and run the scenarios and produce a scenario analysis report. And in the end, we actually perform a optimization analysis. The goal is to design this to-be model of your operations. So we run optimization analysis and we figure out a to-be model design. And of course, there will be engagement with yourself and with the client, and we agree the final design and we simulate it and document the result for you to implement it. So typical schedule will look like this. So there are a few overlapping activities, and all of the steps in the approach that I have shown earlier are there in the schedule. This is only typical. It's not always 5 weeks. If it is a simple plan or a simple operations, very few steps, and pretty much you're just wanting to test something very quickly, it could be a week, or it could be a couple of weeks, or it could be 7 or 8 weeks. It depends on the complexity of your operations and the thing that you want to achieve out of this project. Now, obviously, in this sort of a project, we will need some data. And the sort of data that is required is around the detailed understanding of the process, of the material and information flows, detailed understanding of the product types and subassemblies, etc., historical data of processing times, inventories, batch sizes, setup times, equipment parameters such as OEE, MTBF, etc., orders data, demand data, and supplier schedules, shifts, staff assignments and schedules, Kanban rules, supermarket data, priority rules, etc. These are some of the things we consider to model. Now, the benefits of predictive simulation are fast, realistic, and accurate prediction of operational performance. Okay, you can get close to the reality. The better the data, the close to the reality you can be. And you can avoid costly mistakes by evaluating your investments in operations before implementation. Okay, you can intelligently, of course, make decisions on that. You can prioritize your operational excellence projects, operational excellence initiatives. You can design greenfield and brownfield facilities right the first time. And finally, you can facilitate Industry 4.0 implementation by integrating the sensor data to the predicting solution. If you would like to know more, or if you want us to help you with your operations, please click the button here and you can submit your information and we will get in touch with you. Or you could write to us direct through email or contact us by phone. Thank you very much for your attention.